Hello, and welcome to this month's edition of the Junior Naturalist Program. I'm Eliza, and this is Christina. And today, we're at Davis Creek Park. This beautiful patch of pine and sage is nestled up against Slide Mountain, just to the east of the Sierra Nevada mountain range.
And mountains is exactly what we're here to talk about today. Do you ever wonder how all of these landforms got here over time? Well, I definitely do. But let's first learn a little bit about where we are on Earth.
We live on the oldest part of the North American tectonic plate, right next to the Sierra Nevada mountains. Geologists say these mountains formed roughly 40 million years ago in the Eocene period. That's the same time that mammals started appearing. The North American tectonic plate is the second largest tectonic plate in the world, and is made up of two parts: the continental crust, where we live, and the oceanic crust, in the ocean. Where we are is called a craton because its core is full of granite and hasn't remelted. Many of these events happened way in the past. They still happen to this day. The largest big rock slide that happened here at Davis Creek off of Slide Mountain was in 1983, when a mixture of dry, wet, and snowy winter caused a landslide, which forced rocks and debris down the mountain into a lake off Ophir Creek. As the rocks hit the water, it spilled out and poured down the mountain towards Highway 395, changing the lives in the area and the watershed, like the streams and rivers, forever. This is only one example of the important way that mountains shape our land.
I always wondered, how did the Earth look way back when in a land before time? Well, we can look at current processes happening like...
Convergence is when two tectonic plates are running into each other, creating mountains like the Himalayas.
Divergence is happening in places like in the ocean, in the Atlantic Rift Zone, and this is where plates move apart, creating space for new crusts to form.
The third and final, strike-slip faults, are where two plates are moving along next to each other. An example of this is the San Andreas Fault in Southern California, or most of the earthquakes we feel here in Reno, Nevada. They move across next to each other, and eventually the pressure that forms makes them move past each other.
And this is just 3 examples of the processes that are currently going on Earth that can show us what Earth looked like way back when. Now that we know a little bit about the geological history of our area, let's learn about how scientists use different information to test how old sections of the Earth are. The first thing they use is radiometric dating, which is just a fancy way of saying they use chemicals to test elements to see how old they are. The second thing they use is index fossils, which are fossils that come from a specific time and only existed in a specific time. So that's how scientists can compare.
Very cool. So index fossils use the fossils themselves to tell how old the Earth around them is. But we can also use the Earth itself to tell how old things inside of it are. See, the Earth is built like a layer cake. And there's laws such as the law of superposition, which says that the base layers, the bottom of the cake, were put there first. And so they're older than the top layers, closer to the crust, or the frosting, you might say. The second law of superposition says that artifacts or fossils that are found in one layer of the cake, say the middle layer, are about the same age as other things found also in that layer, because they were deposited about the same time. Now, these are used by paleontologists and anthropologists alike, but anthropologists not only study these ancient things, they also study how the environment and humanity are impacting each other to this day. Let's go learn a little bit more about how humans and Davis Creek have worked together for a long time. The trees here were mostly cut down in the 1800s for lumber to build stuff in the area. Thankfully, they've mostly grown back so we can enjoy them and enjoy this park, which was officially named Davis Creek Park in 1968.
Caw-caw, the JNATS rock! Hey everyone, don't forget about the hidden JNATS rock, which is right next to the pond in these bushes, but don't go too deep in. Remember to be safe at the park and stay on the trails. In addition to admiring the mountains, there's quite a lot to do and see here at Davis Creek Regional Park, including activities such as picnicking, bird watching, fishing when there's enough water, camping, hiking or walking, horseback riding, a fun game of horseshoes, volleyball, different interpretive programs, the junior ranger programs, and photography. The possibilities are endless. This park also features several unique trails, including a nature trail around the pond, a 1.7-mile discovery trail that circles the park, and lastly, a 7.5-mile Ophir Creek trail, which winds up the mountain to Price Lake and the Truckee Meadows. You can see a field of tumbled granite going up this trail. Tumbled granite came from a rock slide. Davis Creek is really fun, but I'm ready to get to our activities for the month. How about you? Our first activity will be a hands-on study of tectonic plate movements. You will need layer of chilled jello on a tray, graham crackers for Earth's crustal plates, and lastly, colored icing. First, put the 2 crustal plates directly onto the jello, or mantle in this case. Then, pull the graham cracker tectonic plates apart. What's formed all the time under the oceans? When 2 tectonic plates separate, there's a weakness in the Earth's crust. Hot magma can then come up between the plates, and as the liquid magma cools, it adds new crust to the plates. Now, let's push the plates together and see what happens. It looks like pushing the tectonic plates together shows to us how at times magma is forced up between the plates, forming volcanoes. Take 2 more graham crackers and place them on a plate with a bit of water for just a few seconds before they become too soggy. Then, slowly push the crustial plates together. This shows us what's happening in India as it pushes into Eurasia. And do you know what mountains have a formation like this? It's the Himalayas. When Earth was one giant supercontinent, Pangaea, India was actually tucked in close to Africa, Australia, and Antarctica. How cool! We'll explore the types of boundaries using Oreos as a fun way to explore and understand convergent boundaries, divergent boundaries, and strike slip boundaries. First Oreo, and we'll show you how to replicate divergent plate boundaries. See how there is space now for new crust to form between the 2 plates? Now, grab a second Oreo, and we'll show you how convergent plate boundaries look when they are coming together. This is how volcanoes can form. For our last, we'll replicate a strike slip boundary between 2 plates. See how the 2 plates are sliding past one another? As an extra activity, we will also be adding I Spy Geology Bingo to the JNATS supply bags. Some of you have seen this before, but this park's a great place to play this game and to hunt for some cool geological wonders. So if you plan on coming out to Davis Creek, don't forget your I Spy bingo sheets and a writing utensil so you can have a mountain of fun out here. We hope you had a fun time with those activities and you had a peak experience today out on our hilarious adventure. Well, that's all from us this month at Truckee Meadows Parks Foundation.
Thanks for joining us again. We hope you have a mountain of fun when you come and visit Davis Creek Regional Park.
And as always, see you next month, Junior Naturalists.